Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about the area between a curve and an intersecting line, okay? We're going to go straight into this, but before I start, don't forget to like, share, and subscribe. And if you've not clicked on the notification bell, I don't know what you're waiting for, please do click on that so that when I post new videos, you'll be the first person to know. So like I always say, make sure you review previous videos and other rules, okay? It's very important that you understand the previous concept before coming here because other concepts build up to this, okay? And also, there are two things I always said throughout this series, that anytime you're finding area under the curve, always remember that the area is either above or below the curve is from that curve or line to the x-axis, okay? But in this scenario, we're going to be looking at a curve and an intersecting line. So I'm going to just write it again, just to be sure. I want you to always remember, okay? Always remember the area above or below the line it is from that line to the x-axis, okay? It's always from that line to the x-axis. So always remember that. It's from the line to the x-axis. So I've talked about above the line. I've talked about below the line. So we're going to talk about the area between a curve and an intersecting line. And it's very important. I'm going to write down the 5 steps now, and the 5 steps on how to solve this. I'll pick an example here, then the next video I might pick one more. Okay, so let's write down the 5 steps. So let's go. So the 5 steps or the 5 rules. Number 1. So the first thing you have to do is that you have to find the points of intersection by equating the curve and the line to solve for the value of x. If you remember from the coordinate, what they call it, coordinate geometry, I told you that when two lines intersect, y1 and y2, at the point of intersection here, y1 is equal to what? y2. Okay, so that means when the curve and the line intersect, at this point here, okay, the curve and the line will be equal to each other. So what I'm trying to say is that applying the same concept of coordinate geometry is what we're going to do here to find the intersecting point, okay? So what you're going to do, you're going to find the points of intersection. Okay, by equating the equation of the curve and the line. Okay, so basically the reason why you're doing this is to solve for x. Okay, to solve for the value of x. Okay. Now, but in coordinate geometry as well, I told you as well that you can also get the corresponding value of y if needed. But in this, most time you don't need the value of y, but just in case the question wants you to find the coordinates. So that means you have to find both the x and the y. Is that making sense? So you can get the corresponding y values by substituting x into any of the original equation of the curve or the y to get that, okay? So I'm going to just write it as a subtext here so that it will be easy for you just in case you come across questions like that. So you can get the corresponding y values if needed. Okay, by substituting the values of x into any of the original question. Okay, or let me say original equation. Okay, original equation of the curve or line. Okay, number two. Now, when you're done with that, you then have to set the lower value of x as the lower limit, okay? And the higher value of x as the upper limit. Then you rewrite the equation of the curve and the line accordingly, okay? So you set the lower value of x as the lower limit and the higher value of x as the upper limit. Okay? Then when you're done with that, and you then rewrite the equation of curve and the line accordingly. Okay. Then number three, then when you're done with it, so usually I advise students to try to sketch the curve at this stage. So try to sketch the curve and the line to see the area covered by each curve using the upper and lower limit. So in step three, I always advise you to sketch, but in some cases, some students prefer not to sketch. They can just go straight, but I prefer to sketch so that I can see the area I'm looking for straight up. Okay, so now we'll now sketch the curve and line to see uh, the area covered by each curve, or yeah, by each curve or line using the upper and lower limits. Okay, using the upper and lower limit. Then when you're done with that, number four, you then integrate the curve and line separately, okay, using the upper and lower limit to get the corresponding area value. So you then integrate the curve and line separately. using the upper and lower limits. So you use this so as to get the corresponding area value. Then number 5, what you now do, so what you do, you subtract or you add. I will explain this. In some cases, you have to add them. In some cases, you have to subtract. So you subtract or you add the area from step 4, appropriately based on the sketch from step 3, okay? So based on the sketch from step 3. So depending what you are given, okay? All right, so let's pick an example so that we can explain this concept, okay? So let's pick an example. So let's say we have example. We're told that find the area enclosed, okay, by the curve y is equal to 25 minus x squared, and a straight line y is equal to x plus what? 13. So let's assume we have this question and you're asked to solve. So how do we go about it? So like I said, there are several ways to do this. In some questions, in some exams, we're going to give you the curve, and then you will now figure out the area. In some exams, you'll be expected to draw the curve, then figure out the area. So depending, I have a video series on quadratic equation, on how to sketch quadratic, sketch polynomial, sketch rational function. So you can go back and have a look, because usually in this kind of question, we're not expecting you to plot it, we're expecting to sketch. So just a quick sketch so that you understand what to do. So let's start now. So what's the first step? So the first step, what I said was that first step, we need to find the points of what? Intersection by equating both of them. So what I'm going to do is that I'm going to just quickly sketch the curve so that we'll be on the same stage, so that you understand what I'm saying. So if we have a curve like this, so the y 25 minus x squared. So if you do the sketching properly, drawing the curve for this. Okay. Now, if you're drawing y is equal to 25 minus x squared, so I'm going to use a purple for this. So if you follow the rules, I'm not going to spend time on this. I've talked about it already. The curve is going to look like this, okay? So it's a translation, 25 units in the positive direction. So it's going to be 25 here for the vertex, okay? And the intercept for this is going to be, the intercept at this point should be -5 and +5, okay? So please, if you've forgotten how to sketch, it will be a good time for you to go and review that, okay? Now for the straight line, x plus 13 is going to be a positive slope, and the intercept is going to be at 13, all right? So the positive slope and the intercept is at 13, so it's going to be somewhere around here. So it's going to be somewhere around this one. Somewhere around here, like this. Okay, and that is that. Okay, so now step one, while we go back, step one said that we need to now find the what? The point of intersection. So we're finding the point of intersection by equating, all right? We're finding the point of intersection by equating the curve and the line. So what we are saying is that the curve and the line, see, in this place, they intersect at this point here and at this point here. Are you seeing it? So we're finding the point of intersection there by equating it. So let's go. So step one, we're meant to equate the curve and the line. So the curve at point of intersection, remember at point of intersection, we talked about this in coordinate geometry at point of intersection. Okay, y1 is equal to y2. Do you remember that? So that means the curve at this point here, the curve and the line are going to be what? The same. So that means 25 minus x squared is going to be equal to x plus 13. So 25 minus x squared will be equal to what? X plus 13. All right, so make this interesting, I'm going to take all this to the other side. So it's going to become will be equal to, we have x squared, all right, plus x, then minus plus 13, then take 25 minus 25, and this will be equal to what? 0. So therefore, then you take it, so it'll be x squared, okay, plus x minus 12 will be equal to what? 0. So this is quadratic equation again, and I have a series on quadratic equation, and I told you there are different ways to solve quadratic equation. You can use the formula, you can use completing the square, you can use factorization method when a is equal to 1, when a is not equal to 1, so you can try so many of them. But I'm going to use factorization where a is equal to 1. I'm going to look for two numbers that when I multiply it, it's going to give me minus 12. And when I add this, it's going to give me 1. And those new numbers will be minus 3 and 4. Okay? Minus 3 and 4. Minus 3 times 4 will give you minus 12. Minus 3 plus 4 will give you 1. So it's going to give us x minus 3 and x plus 4. And that will be equal to what? 0. So, as usual, so x minus 3 will be equal to 0, or x plus 4 will be equal to 0. So therefore, x will be equal to what? 3, or x will be equal to minus what? 4. Are you seeing it? So now we can go back to the curve now, all right? So we can go back to the curve. So we now know the x is what? Minus, the x is 3 and minus 4. So we can now say that this point here is what? Minus 4. Well, this point here is what? 3. Is that making sense? So this point here is minus 4. This point here is 3. Now, step 2. Okay? So step 2. Step 2 now said set the lower value of x as the lower limit and the higher value of x as the what? The upper limit, okay? And for the equation and the curve. All right, let's go back. So now, so the equation and the curve, we'll have to set it now. So step 2. So we're told, so we know already from this that the curve, which is the purple one or the blue one, yeah, the purple one, we know that the curve is y, okay? Y is equal to 25 minus x squared. And we know the red one that y is equal to x plus 13. So both have an upper and a lower limit. So we're going to set it now. So step 2. So for the curve, so let's start with the line, okay? So the line, we know the line, we're going to set it between the upper limit and the lower limit. So the upper limit is 3, the lower limit is -4, okay? Lower limit is -4. And the curve is x plus 13. Then for the curve, the same thing. So we're setting for the curve now. For the curve, the upper limit is same thing, 3. The lower limit is -4. And we have it to be 25 minus what? X squared. All right. Now, so let's go to step 3. So step 3, what does step 3 say? So step 3, we are meant to what? We are meant to sketch the curve and the line to see the area covered by each of them, all right? We have to sketch each of them to see where the area is covered. So let's go back. So let me see if this software is going to allow me to make, to copy, if it's going to allow me to do that. Copy all this. Right. Copy. Let me see if I can bring it all the way down here. And paste. Yep. So that is good. So you can have it here. Then I can remove this. For step 3, this one. Okay. So write step 3 here. All right. So it will save me from drawing again. All right. Step 3. Step 2. All right, let's go. So we need to see the area covered. So remember I told you that when you integrate a line, it gets you from that line up to the x-axis, okay? So let's start now. Let's start with the line. We have this line. If I integrate between -4 and 3, it's going to give me between from the line all the way down to the what? To the x-axis. Are you seeing it? So it always gives you from that line all the way down to the x-axis. Okay? Now, the same thing for the curve. If you integrate the curve as well, it's going to also give you from the curve all the way to the x-axis. So it's going to give you from this point, if you integrate the curve, that is, if you integrate this curve here, 25 minus x squared, it's going to give you all this part here, all the way up to the what? The x-axis. Are you seeing it? But the question is asking you the area bounded by both of them. So what we're interested in, we're only interested in this place here. Are you seeing it? So we're looking for the area enclosed by the curve and the straight line. So we're looking for this part here. Okay? So now if you go back to the question, you will notice something, that there is a particular way we can find it. So that means the blue one, or the blue shaded region, is all the way this side here. All right, it's giving you everything here. The red one is giving you from the line all the way to the bottom, but I'm just interested in only what? This part here. So what do you do? So it means that in order for me to get that green part, what I have to do is I have to integrate the blue one, which is giving me everything, minus the red one is going to give me only this part here. So I'm going to integrate the whole curve, the purple one, sorry, get an answer. Then I'll integrate the red one, which is the line, get an answer, and it's going to give me the space that is here. So remember, I'm only interested in this space up here. Okay? So let's now go to step 4. That's why I said in step 4, you now have to sketch the curve to see, you have to integrate them separately using their upper and lower limits. Then you have to then subtract or add in step 5. So that means in step 4, we then have to integrate them now. So step 4. So what I'm going to do is that I'm going to integrate the curve first, which is the purple one, which is going to give me all these points here. Then I'm going to get that part. Then I'm going to integrate the red one to give me this part below. Then to get the upper space that has been enclosed, I'm going to subtract both of them in step 5. Okay, so step 4. So step 4. So I'm going to integrate the curve now. So we have one, so we're doing the curve now. All right. So we're integrating between 3 and minus 4. We have the 25 minus x squared. So 25 minus what? X squared. So the same principle I taught you how you do definite integral. You open the bracket. 1 integrate 25 is going to give us 25x minus 1 integrate x squared is going to give us x. 2 plus 1 will give us 3 divided by 3. Okay. Then all between 3 and minus what? 4. Okay. Then what do? You substitute 3 into this, minus 1 you substitute minus 4. So this is going to give us 25 into bracket 3 minus 3 cubed divided by what? 3 minus, now we're going to substitute minus 4. Will give us 25 into bracket minus 4 minus 4 raised to the power of 3 divided by what? 3. So when you now press this to your calculator, it's going to give us 434 divided by 3 units squared. Okay, so that means this whole purple region that is being covered here, this whole purple region is what? Is what we just calculated for. Now, the next part now is that we need to calculate the area covered by the line, the red part now. So we need to go and look at the line now. So we have to calculate the line to get the area covered by the line. And the line is same thing between 3 and 4, 3 and minus 4 as well. So between 3 and minus 4, and that is x plus what? 13. So between 3 and minus 4, and we have x plus 13. All right. So the same thing, we're going to integrate this. So it's going to be, remember I said the x has a 1 here, all right? So you're going to become x. 1 plus 1 will give you 2 divided by 2 plus 13 is going to give us 13x between 3 and minus what? 4. So similarly, you do the same thing. You substitute 3 minus when you substitute what? Minus 4. So it's going to give us 3 squared divided by 2 plus 13, 3 minus 4 squared divided by 2 plus 13 minus 4. Are you seeing it? And when you press your calculator for this, it's going to give us 175 over 2 units squared. Okay? Now, but we are interested in this, in the area, this part here, that's the green part. We're interested in this green part here. So we're only interested in this part here. All right? So how can we get that part? That means it's going to be the purple one minus the what? The red one will give us this green part that we are having here. All right? That's the part we're interested in. So it's going to be the curve minus the line, which is step 5. So step 5. So the area of interest. So the area of interest, what we're interested in, the green part. The area of interest is going to be equal to 434 divided by 3 minus 175 divided by what? 2. And when you solve this, it's going to give us 343 divided by what? 6. Now, in some cases, you might want to leave this in decimal points, or you can say 57.2 units what? Squared. And that is how you solve this. Okay, so basically you just follow the steps. You at the point of intersection is where both of them are interested in. Now in this question, we're not asked to find the y coordinates, so it was not necessary in step 1. So you go to step 2. The lower values of x is going to be the lower limit. The upper values of x is going to be the what? The upper limits. All right. Then when you're done with that, the next thing that you have to do is that you then have to then try and sketch it and see. Then you will see that for the curve, it's from that curve to the x-axis, from the line to the x-axis, then you will now find which part are you interested in. Then in this case, we need to subtract, okay? In some cases, you need to add. So depending how the question comes, the shaded region is what you're looking for. But in this case, we need to subtract. Then you subtract it and you get the answer. All right, so that'll be that for this video. In the next video, I'm going to give you another example to try. We're going to solve an exercise as well. So I'll make sure you subscribe and click notification bell so that when I post the next video on more examples on having a curve and intersecting line, so you'll be the first person to know. All right, so I'll see you soon in the next video where we're going to solve more examples. All right, see you soon.